Welcome to Session 16, Statistics, Center, Spread, Outliers, and Weighted Values. This lesson develops mathematical reasoning that stays reliable when a problem looks unfamiliar. You will learn to choose resistant or sensitive center measures, to calculate weighted values, and to interpret spread and variance. These are connected habits, not isolated tricks. Keep a pencil ready. We will build a mental model, use a repeatable method, solve a demanding example, diagnose an error, and finish with an independent checkpoint. Start with this principle. A statistic is useful only when it matches the question and data shape. Use this visual structure: center, mean/median spread, range/variance. Read every symbol and label before calculating. The first goal is to choose resistant or sensitive center measures. Connect it to the second goal: calculate weighted values. Correct calculation begins with correct interpretation. When the surface details change, search for the same relationship underneath. Transfer means choosing the structure from evidence rather than waiting for a familiar-looking example. Step 1. Order and inspect the data. State the target and preserve its units or conditions. Step 2. Select the statistic that answers the question. Use a separate line so signs, factors, and labels remain visible. Step 3. Apply weights or squared deviations. Keep the reasoning efficient, but never skip an operation that could hide an error. Step 4. Explain direction and magnitude in context. Verification is part of the solution because it tests the answer from another direction. Signal 1 is one extreme outlier. Respond by remembering. Compare mean with median. Name the response before calculating. Signal 2 is n-equal component shares. In that case, use a weighted mean. The form tells you which tool fits. Signal 3 is spread around the mean. Remember, use square deviations. This separates plausible work from valid reasoning. If you cannot name the signal, pause and classify. A deliberate choice of method is usually faster than repairing a rushed setup. Here is the challenge. An overall return is 6%, with half at 8% and half at R. Find R. Restate what is requested before touching the choices. The first move is order and inspect the data. Apply it directly to the quantities and conditions in this problem. Now use the core reasoning. For equal weights, 8 plus R/2 equals 6, so R equals 4. Keep each equality, comparison, or unit conversion visible. Pause for a midpoint audit. Check copied values, signs, units, restrictions, and whether the current result is the requested quantity or only an intermediate value. Continue by applying this control. Apply weights or square deviations. The explanation supports one option without relying on its position. The mathematical conclusion is 4%. State it with any required units, interval notation, or restrictions. The final answer is 4%. Compare it with the exact target and reject any choice that represents a common intermediate step. Verify from another direction. Recompute from the raw values and test the effect of an extreme value. The check should use evidence independent of the original calculation whenever possible. Try this checkpoint without copying the example. A data point is 4 units from the mean. What is its contribution to the squared minus deviation sum? Decide which mathematical fact controls the answer. Pause and write one line of reasoning before committing. A visible decision is easier to inspect, explain, and correct than an unsupported guess. A focused hint. Variance uses the square of the deviation. Use the hint to repair the setup, then finish the reasoning yourself. The accepted answer is 16. Explain why it works, and name the earliest line that would reveal a likely error. The central message is to choose resistant or sensitive center measures. Combine that with the discipline to calculate weighted values. Finish by remembering to interpret spread and variance. A result becomes dependable only when the method and verification are both clear. Reflection. Which value has the greatest influence, and why? Name the exact point where an incorrect path would first become visible. Practice one fresh problem for 8 to 12 focused minutes. Keep the work readable, verify independently, and carry the routine into the next session. Before moving on, close the notes and explain the method aloud from memory. Then invent one small variation, predict how the answer should change, and verify that prediction with a complete calculation.